Okay, I have removed the Y servo motor off the gantry, pulled it back here. I'm going to plug it into the Y, and I want to get a video of exactly what it's doing. So it's currently plugged into the Y. We can see it here. And let me pause the video for a moment and put a piece of tape on that thing. Okay, now I'm going to put a piece of tape on this so it can be easier to see as it spins or doesn't spin. Okay, plugged in. CNC, servos disabled, servos enabled, and a G28Y. And it tripped. Didn't have anything to do with running into that. Do it again here. Servo disabled, servo enabled, G28Y. It's going to prove me wrong. Alright, we're going to fake it out and trip the switch. Alright, so now it thinks it knows where it's at. So Y100 immediately tripped it. Okay, servos are disabled. I'm going to turn the machine off. Okay, we got no backlash on X, which is good. X is unplugged. Motor is going to be plugged into X, and we're going to see how that responds. And we will turn it back on since that's required. Now the motor's plugged into the X servo. Servos are enabled. So we'll do a G28X. You know what? I bet that thing's got to have a motor plugged into it. All right, so now the old X is plugged in Y, and Y motor is plugged into X. Servos disabled, servos enabled, G28X. Alright, so it thinks it's moving it. Alright, now we should have that extended out, so it thinks it's setting at X0, so we're going to do X60. Trip the servo. X servo tripped. So it tells me that for some reason the motor is failing. Either it can't detect the movement or it's dragging for some reason. All right, X is being hooked back up. And here's the bad Y. So the Y failed on this controller, this motor failed on this controller, and on this controller. And that's at when I tell it to move at a rapid movement. And the rapid movement is set at 600 on the Y, and it's probably 1,000 inches per minute on the X. So either way, it failed on both. So the question is it the servos that's the problem? Or I should say the indexer. Where it receives the pulse back that it moved. All right, I'm going to pause the video. Okay, so here's the servo. All you folks watching at home, you can see over the camera, or you can come back and watch it. I'm going to pull this off and see what's going on. Not pulling in the motor apart, I'm just pulling the back cap off of it. This should have the encoders in it. Oh wow, if you can see, it is dirty, and that's an underestimate. Okay, the screws, I can't tell if they're fixed. Nope, they're not fixed in. 1, 2, 3. All right, so this is a die-cast aluminum cover, looks like, and wow, everything is really dirty. So the windings, you can see down inside there. Here's the encoder. Let's remove that. So we got our 2 steppers. Wow. Oh, yeah, the encoder wheel has a very light, it's a thin piece of metal with extremely small grooves, and they are scattered throughout here. And the reason I would say it's failing is the sensors are picking up, are being blocked by the moisture. I think that's the right size. Oh, it sure is. Okay, so the objective here is to clean that thing. It's got to be why it's failing. Or at least, if it's not why, it's certainly helping fail because of it. Okay, air hose and extremely light pressure. That's under the plastic shield. That optical sensor's got to be filthy. It's like it's oxidized on it. I don't know if you can see it or not. Let's get it right here. Okay, trying to focus it there. That encoder wheel, I'm moving it, tilting it slightly so you can see it, is where everything is right there. And actually it looks pretty flat. You can see the oxidation on it, and that's a problem. Yeah, there are actually multiple rings there. So there's an outer ring of a wide, what looks like to be a pattern of maybe a 20,000th of an inch. Then there's a small ring inside that consists of very small grooves that are horizontal. Then you got another vertical groove set of circles around that are maybe, I don't know, 3/8 inch long. And there's a second set inside that, 3/8, and then there's another set inside that, another 3/8. So 1, 2, 3, 4, looks like 5 optical sensors that I can identify. All right. Refocus. Okay. This is not a very good cloth. Let's see what else we got. Oh, I can even read serial number on it. If I had to guess, I'd say it's a thin mylar sheet of some kind. Well, there's another set out in there too. They're on the outside. Looks like it's a zeroing point. Very small. In theory, this thing ought to be just perfectly clean, but seeing that it's set for so long, plus we transported it here, and one little spot right there that I don't like. I think it's in a non-concerning place, but boy, I don't like it. Okay. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, either 9 or 10. Let's see, that'd be 1, 2, 3, 6. And 4, that'd be 10. So there are 10 data lines coming back out, and that would relate to 5 optical sensors within this little piece right here. Alright, power is off. Alright, stop. Okay, camera back on. There is the motor with the optical sensor removed. This optical sensor cover. And I'm going to try and make Y move again. All you people at home, somebody's standing by on 911. Servo's disabled. Servo's re-enabled. G2028Y. Oh, look at that. Moving nice and perfect. Holy cow. It's not jumping, it's not going fast, not doing anything. Alright, so we're going to trip the Y, and it hit home, and there is, Y is now measured. Now we'll go Y 50. Oh no, hey, we went right to 50 inches. So Y 100. Alright, we are there. Now we go Y 0. There's Y. Going the other direction. We're accelerating to our maximum acceleration. We did not trip. Ah, hot dog. Fantastic. Close this thing down. Tabs. Alright, here's our file. Let's see. Win CNC, we're going to run edit the Win CNC. Notepad or WinCNC file. Let's sucker up all the way. Let's go down here to where Y acceleration and change to 600. We'll set it back to 1,000. This is Y axis 1,000. And just save that and exit. WinCNC, put WinCNC. There's all this other junk. Back into WinCNC. Okay, so Y 100. I'm going to move to 100 inches, acceleration 1,000, and hopefully not get a trip. Yes! Fantastic! Y 100 with no issues whatsoever. We got a red X and a red Z because it hasn't been measured. So, the encoder was dirty. Alright! Not a bad motor, not a bad cable. Bad, dirty encoders. Alright, I'm going to stop. There we go. Apparently I was talking to myself and the good folks at home. I did get a good video of cleaning the encoder. I hope. Look at that. No, I wrote the little program to do the routine, and then I just did just copy and pasted those 6 lines, whatever it was, 4 or 5 times. It ought to be done now. Or one more time. I don't know. I just, oh, that's wonderful.
Yeah, that's awesome.
So, as soon as it finishes this, I want to put those bearings back together. So let's run it down again down there. And shut it off. I don't want any. It jumps here. Well, I didn't do it that time. The previous times, maybe it was because of the encoder, I don't know, or because the motors had something going on.
Didn't do anything there.
So, all right. You feel like getting your hands just a little bit greasy?
Yeah.
Hopefully not too much, but
Sure.
oh, let me turn the camera off here.
Or here, actually, let me put the rest of those.